Let's take a look at question number 11. A 3.45 meter segment of wire has a mass of 162 kilogram, carries this current, 1,570 amps. And this is going eastward. So how strong would a magnetic field have to be to levitate the wire in place? So that's a key word in here. To levitate means to stay in the air, which means that the magnetic force and the force of gravity should be equal. In which direction should the field be oriented, assuming that it is perpendicular to the current? So let's try to envision the situation a little bit. So we have a wire with a certain mass carrying this current, and the current is going eastward. So let's draw the current eastward first. So remember that this is east. And this is the wire, L. And the current is going in this direction as well. Now, we are going to have to find how strong the magnetic field would be in order to levitate the wire in place. Now, remember that the force of gravity will always go down. And I'm going to make it a different color in here. The gravity will be going down, which means that we want the force, the magnetic force on the wire, to be up. So if the magnetic force is up and the wire is going eastward, we're going to have to use the FBI to determine the direction of the magnetic field. So force will be the direction of the thumb, B is the direction of the middle finger, and I is the direction of the current. Now, so far we know the direction of F and we know the direction of I. So we're going to form the FBI, or place the three fingers in FBI position, and then try to change the orientation of your fingers in such a way that it is following the current. I always start with the current, so following the current, and then rotate your hand. Okay, keep the pointer in the direction of the current until the thumb will match the position or the orientation of the force, magnetic force. So we're going to say that, so based on what I see in here, is that if I have current going eastward and the force going up, it looks like the magnetic field is going through the page, so away from me. So what that means is that this is going to be the magnetic field line, so away from me. That would be the value, the direction of B. Now let's go over the calculations. Now, we said that to levitate means that the magnetic field, or the magnetic force, must be equal to the force of gravity. Now, force of gravity is mg, and magnetic force is ILB sine theta. Now, we're told that the angle theta is 90 degrees because they are perpendicular, and that's what it is given in the problem. So, and sine of theta will be equal to sine 90, which is equal to 1. So therefore, we're going to have here ILB equals mg. And from here, we will have to find the strength of the magnetic field, or in other words, we have to find B. So we'll isolate B here, IL, and then with a mass of 1.62 kilograms, so very important to look at unit measurements, gravity of 9.81 meter per second squared, and then we have a current of 1,570 amps, and the length of the wire 3.45 meters. So we want this to be in meters. Remember, this is in meter per second squared, so the units have to be compatible. So we're gonna calculate the whole thing here. We have 1.62 multiplying 9.81, and that will divide 1,570 times 3.45, and that will be 0.0029. So the magnetic field will have a strength of 0.0029 Tesla, and the direction of it is going to be through the page or away from us. I hope this made sense. Thank you for learning with me, and bye for now.